this meeting will be recorded and I'm going to post it later, and I just want everybody to know that, all right? So you're being recorded right now. If you say anything, it's no big deal, but I just want to let you know. So anyway, here we are in Canvas, and here's our class. Let's go in there. Now, first thing I wanted to let everybody know was if you go under announcements, first thing I sent out was this Mymathlab enrollment information, okay? Tells you exactly what to do to get enrolled into Mymathlab. And that's important because that's where all of the assignments are going to be this semester, all right? So if you haven't done that yet, try to do that as soon as you can because our semester is only about 7 weeks or so. So it's going to go by pretty fast. All right. But you would have got this to your at my.tccd email. But if you ever wanted to look back at the announcements, if you can't find them, you just go to announcements right here in Canvas. All right. So next thing I wanted to show you was that if you go to modules, that's where everything is going to be posted. Everything I want you to see is going to be in there. And under Welcome Start Here, there's this thing called the course information document. And I think that is, it's all the information I want to put in the syllabus, but I think it's a little bit easier to read, okay? So let's see, let's look at that real quick, okay? I'm gonna open that up. And I would like you to read this, okay? I'm not going to read it all right now, but I want you to read it on your own so that you know what to expect throughout the semester. All right. And I'm going to tell you some things that I think are most important for right now, though, just so that you know them now on the first day of school. So, first thing about me. So, I told you who I was. My name's Jeff Brignac, and I would prefer it if you call me by my first name. Okay, so you don't have to say Mr. or Professor or any of that. You can just call me Jeff. I'm most comfortable that way. And next thing is about how to contact me. Now, see, I get messages through Canvas, but I would actually prefer that you not contact me that way. I like my Gmail address a lot better. So actually with TCC, I have 3 email addresses, okay? And it's simpler if everybody contacts me at the same place, all right? So this is my Gmail. You have one of these too. This is what's easiest for me to check no matter what I'm doing. So please use that. So I'm going to ask you not to use this, not to use the Canvas, all right? And it's not the end of the world if you use the Canvas. It's just I might not get to it as soon as I get to this, all right? Anyway, so here's what we're going to be doing this semester. So your grade is entirely based on 4 tests, 4 quizzes, and 16 homework assignments, all right? And there's the grading formula. The tests have most of the weight. All right, they're 75%. And then the quizzes and the homeworks are significantly less than that. All right, now you'll see all of your scores for all of the assignments posted under grades right here. This is the grade book. All right, I'm going to put all your scores right here, and you'll see that a final grade gets calculated by this formula. So if you're curious if your grade is correct, you can use this formula right here to check it. All right, include the drops. Lowest quizzes drop. 5 lowest homework scores are also dropped. Okay, so that's how the grade's going to get calculated. And you find the assignments on Mymathlab, and we'll talk about that in a minute. All right. So there's also a calendar. I think this is important if you want to plan ahead. Some people really like to plan ahead and write down the due date for every assignment and so on. And if you'd like to do that, here's the full calendar for the semester. Now, so it looks like this. You've got 4 assignments, then a quiz, then a test. All right. Then another 4 assignments, then a quiz, then a test. And you can work at your own pace. All the assignments are available at once, but I think it makes the most sense if you go through them in order naturally. All right. And the tests are the majority grade, but I've got it set up that you can work these assignments as many times as you want to keep improving your score. If you miss something the first time through, you can go through again and get it right. And if you take advantage of that and work this quiz until you're satisfied with your score, then that's a pretty good predictor of how you'll do on the test. Okay, some people work the quiz, 3 times, 4 times until they feel like they're ready. And then when they get to that point, I tell them it's time to take the test. All right. And it usually works out pretty well for everybody that way. Now, here's some common sense things I would ask, or I would recommend that you not wait until the day something is due to start working on it. Okay. So for example, I see that these 2 assignments are due the 11th, then the quiz is due the 12th, then the test is due the 13th. Well, I don't recommend that you actually start them on those days. That's just when they're due. And they're due like that to give you some flexibility. It's nice if you can work ahead, but that's not always possible. And these due dates are there to allow you for some flexibility. Okay. Anyway, I think that is it for what I wanted to tell you about in here. I might come back to it a little bit. But I want you to read this, okay, just so you know what to expect. Okay, there's some other information in here about what to do if you miss a test or so on. And I want you to go ahead and read that so you'll know for yourself. Now, I'm going to go back to modules for a second. And let's do this. Here, let me get that calendar back up. All right. Where do you find the assignments? Okay. So I'm going to go back here to announcements. And remember this Mymathlab enrollment information. If you go to this website and you enroll, as it says here, then you'll end up over here. Okay. And when I log in, I see all my classes that I'm responsible for. And here's our class. And you'll probably just see this one. Okay. So let's say that we go in here. Then you'll find all of those assignments right here naturally under assignments. Okay. I wouldn't pay too much attention to the gradebook. There is a gradebook here in Mymathlab, but it doesn't account for the weights. It just averages all your scores together without considering that the tests are most of the grade. Okay. Nonetheless, there is a gradebook, but I want to emphasize your official grade is over here in Canvas under grades. That's where I'm going to put everything. That's where you'll see that the correct grading formula is applied as I explained it to you. Anyway, so let's go over here to Mymathlab and go to assignments. Now I'll tell you a little bit about this, and I want to do this in kind of an informal way. So if you have a question at some point, just turn your microphone on and you can interrupt me. It's no big deal. I think that would be the easiest way to address any questions you have as we go through this. All right. So let's see. Here they are. Here are those assignments. Here are the due dates. Okay. Right? From that calendar. And you can work them however you want to. You could start with the quiz, even though I don't recommend that. But let's look at this first one. And you can, here it is. Here are all the questions, 20 questions, and you can work through it any way you want. You could start the first question. You start anywhere you want as long as you get to all of them. You can skip around a little bit and so on. Now, I don't know. Let's say we're doing this one. I'll use this as an example so that you can see what to do. Say we are on Mymathlab trying to do an assignment, and we get to whatever question it is. Okay. So maybe I'll work this question on paper. You know, I got some paper on my desk and I work it out. Maybe I have a notebook to stay organized. I would recommend being organized because you can use notes on the test. All right. But anyway, say I got my notebook and I'm being organized about it, trying to keep everything in one spot, try to keep it neat. And I work this problem out, and I think the answer is 9, and I type in 9. Okay. So I type my answer in here, and then I put check answer. All right. And tells me if I get it right away. I get instant feedback on the homework assignments. Okay. So that's the basics of it. That's how it works. It's Mymathlab is a computer though. Okay. So let's see. The answer to this one is actually 4. But if I type something like x equals 4, even though 4 is the right answer, it thinks it's wrong because Mymathlab is computer software and it doesn't understand the difference between you thinking the answer is 4 and you typing in x is equal to 4. So that might frustrate you a little bit, but it's no big deal because if you think you've gotten an answer correct, but Mymathlab is counting it wrong, then tell me right away. Okay, I can go in, I can look at your answer, and if it's just something silly like that, then I can change it from incorrect to correct, and it's no big deal. Okay, so keep that in mind as we go through the semester and you're working on Mymathlab. Okay. Anyway, so I put x is equal to 4. Then I realize I'm not supposed to do that. It's just 4. And then I get it right. Okay. Another thing, if you want more practice, because for most people, math does take some practice. If anytime I'm working something and if I want to see more of it, I can have it generate a similar question. Okay. And there I get something similar with different numbers so I can practice it again. All right. Now, here's another thing I need to mention. How are we going to learn this? So you can do this. So do you see these assignments? Mymathlab assignment 1, 1.1, 1.2, 1.3, then quiz 1, then test 1. Okay. Here's how you can go about learning everything. I'll cover some of this material on our Saturday meetings that we're having right now. But we can do this also. Let's go to modules in Canvas. I'm going to look under test 1, and then there's a document, videos for test 1. I have made videos already for everything. You can work at your own pace. You know, if you want to go through all these videos, notice how they're sorted by assignment and work all the assignments this week. You could do that. I mean, it's all available to you right now. Okay. So this is everything. Everything that I could possibly show you on these Saturday meetings is already here. Okay. So what you could do is go roughly in order. I've got these in order for the most part of the way that you see them in the assignments. Okay. And if you want to watch the videos as you do the assignments or before you do the assignments, if you want to take notes, if they're videos, you can pause them. You can watch them more than one time. You do this however you want to, but I've made all of the material available to you already, okay? All right, so that's that. Now, you could watch those in addition to, working these assignments. And those videos are just like I would present it in class, okay? If we were sitting in a traditional classroom on campus, let's say. Now, here's another thing that you could do. If maybe the videos aren't for you, maybe you just don't like them, maybe you just don't want to watch videos. That's okay. I guess I'm for whatever works for you, whether it's the videos or something else. Here's something else that you can do. When I'm in my math lab, there are help features down here. Okay. So you could look at this, view an example. I think this is pretty nice. It will just kind of walk you through step by step everything you need to do to solve that problem. Okay. All right. You could learn it that way because it tells you what to do. Maybe it leaves some of the steps out, and if you need reviewing about some basic things, it doesn't do that. But if you have a basic idea of what's happening, this might be enough for you. Okay. You could use help me solve this, where it's the same thing, but it will want you to give some answers along the way just to see that you understand it. It's a little more interactive. But both of those will show you what to do. Okay. All right. So there's that. And also you can ask me for help. All right. So let me check something real quick. Whoops. All right. So if you now I can help you also. That's what I was saying. I can do tutoring online just like this. I obviously have the webcam, I have Teams. You'll see in a minute that I have a writing tablet, and it's like I have paper and pencil, and I can write and communicate with you and explain what I'm doing as I'm doing it. And that's one way I can help you. So if you need tutoring, go ahead and ask for it. Contact me anytime and we can set something up. And another thing that you can do if you just need a quick answer about something is ask my instructor. Okay. All right. If you use this, it will send me a copy of whatever problem you're working on. And that way you don't have to explain what problem you were doing, what it said, etc. Because it can be hard to explain what the problem is asking if it's complicated. So just use this. It sends me the question, and you can just tell me where you're stuck or something like that. And then I'll send you a video solution. Maybe I'll write it out. I'll find some way to tell you what you need. Okay. So that is how to use MyMathLab. That's the basics of it. All right. Now, remember what I said, you can work the problems as many times as you want. So, if I'm getting this one wrong, I can keep putting an answer in and I can keep checking it. All right. And if I get it wrong 3 times, I'll have to do a similar question to start over, but I can keep trying, is the point. I can keep trying until I get it right. Is the answer 1? No. I try it again. Is the answer 2? No. So I keep trying. And eventually, whether you find your mistake or you ask me for help, you'll get it right. Okay. All right. So just keep trying. And for sure, ask for help if you need it. I wouldn't want you to struggle to you're just at home by yourself trying to work things, struggling, getting frustrated. I don't want that to happen. So if you need help, please ask for help. Let's see. All right, here's one more thing. On the weekend, so I check my email, but I think the best way to ask, there's Melvin again. Okay, that's my cat Melvin. He might appear on the video. But one quick way to get help, like if it's the weekend or something, I'm going to give you my cell phone number. 817-271-2601. Okay. Now you can text me anytime, but you know, it's like this might be best if it's the weekend or something and I'm not sitting at my computer, or at night or something like that. So there's my personal number, and just say, when you text me, say, I'm in math 1314 82001 and ... You can say whatever you need help with. You're stuck on something, can't get something to work, whatever, right? Anytime. I stay up super late, so don't worry about texting late at night. And that's a real easy way to get help. All right. Okay. So let's see. Where was I? Back to Mymathlab. Okay. So let's see. I'm going to close this. All right. Now, if you don't finish the assignment in one sitting, you can get back in there and work it later. Now, so you get infinite attempts on, like you can just keep doing those problems until you get it right. You have to ask for help. You ask for help, right? And see the quiz, it says how many attempts do you get? Unlimited attempts. All right. Now, the only thing that you don't get unlimited attempts on is the test. All right. But you can use notes on the test, and you can practice the quiz as many times as you need to become ready for the test. So the test is where, like, I want it to come together, and I want to see that you practiced and that you got your notes organized and that you're ready to go through it. Okay, so that's the only assignment that you don't have unlimited attempts on. I just want you to get to that point and show me that you're ready. And I believe that if you put your time in practicing, if you get some good notes together and you're organized, then the test won't be a problem for you. Okay, so I think that's how it's going to work. All right, now, so that is all I can think of to tell you about Mymathlab. But let's go over what you know. So you know, I post the videos already. It's all out there. Okay, every topic and all the assignments, so on and so forth. And you know that all the assignments that you're getting graded on are right here. Every single one of them. Every assignment that you get a grade for is on this calendar and can be found on Mymathlab. You can work ahead, but I only post the assignments for one test at a time. So after we take the first test, I'll put all the assignments up for the next test, and so on and so on. Okay. Anyway, so let's see. Let's do this. I don't know what that thing is. How about this? Okay. Let's I
Hey,
said you
Jeffrey.
could interrupt me anytime you want for a question. I thought I heard somebody turn their microphone on.
It's Amber. I'm sorry.
Hi there, Amber.
Yes,
Did you have a question?
I do. So I know you only open up a certain amount for each test. If
Mm-hmm.
we are going on a vacation and won't have access, would we be able to get access to them before we leave, like early?
Sure. Yeah. So I'm up for opening them a little early, like say a week early or something like that.
Mm-hmm.
Um, I can't. The thing is, I can't open them individually.
Okay.
And if I like open a bunch of assignments real early, then I worry about the class working through them in an uncoordinated way. So how about this? If you're planning on going out of town or something like that, you need access a little bit early, let me know. But are you thinking like a week early or something like that?
Yes, only because I'm leaving for a cruise and I'm gonna
Mm-hmm.
be gone for a whole week.
All right.
So
Yeah, I
I
gotcha.
don't I
Yeah,
don't
I can
know
do
what
that.
that works. Okay.
Yeah, that's no problem. Just let me know when that time comes up. Give me a little bit of notice about it, and I'll make it happen for you.
Okay. All right, perfect. Thank you.
All right. Okay, anything else?
So I do have a question.
Okay.
Um, I don't know how to go about contacting anybody to get the access code for Mymathlab. I purchased it online through the bookstore,
Mm-hmm.
but I never had any kind of like email sent to me with anything on how to access it.
Okay. Um, I will get you that information. I don't know the number to who to contact, but I can find out. Can you do this? Send me an email to this. See this address, jeffrey.brignac@my.tccd.edu. Send me something there, and I will find out who you need to contact and send it back to you.
Okay, thank you.
Now, but here's something you can do though, so that you don't get behind. You can go ahead and enroll and just select the option for 14-day temporary access. And then that'll get you in the class. And then when you get your access code, you can put that into the account you create, and it will
Oh,
convert it to full access
oh, thank you.
because you're just missing that access code. And once you get that, you can put it in and you'll already have start on the class and you'll have your account ready and all that.
Okay, thank you.
All right. Okay, anything else? Okay, so let's do some math because in the meetings, I want to go over some stuff like this, uh, stuff about the class that everybody needs to know. And I also want to do some math. Some of the stuff for the assignments I want to get you ready for. So let's do some of that at this point so that when you start working that first assignment, you'll already have some exposure to some of the problems that are there. Okay. Now, so let's see. I'm still sharing, and there's Melvin again. Let's go up here. So this is what I was hoping to work through today. All right. And this is some of the stuff that you'll see for the first assignment. Now, our meetings that we have, the intention of those meetings is not that I cover everything that you're going to see for the assignments. I can do some of it. It gives you a time to ask questions and things like that. Maybe gives you some time to work on things with some feedback from me, etc. But I can't go through all of it, and that's not the intention. Um, I have provided you with everything though, because I have videos for every topic, right? Right here. So, but we'll go through some of it. So let's do this. Let's talk about equations and solutions, because some of the problems on the first assignment are just about solving equations. So I thought we'd start there. If you have an equation, say like this one, how would you know if you had a solution or not? So here's an equation. Say, is 7 a solution or not? Is -9 a solution or not? How would you know? So you could think of the equation like this. Um, Sometimes people tell me that the thing that's confusing about algebra is the letters, the X's and Y's and Z's and all that kind of stuff. So maybe we could think of this equation as the X is just like an empty spot, and we're trying to figure out what number goes in that spot. So this equation says the square root of 63 minus 2 times some number is equal to that number. What's that number supposed to be? I mean, that is what it says. Now, how would you know if 7 or -9 were actually solutions? Well, you'd plug them in, okay? So here I get 63 minus 2 times 7, okay, is equal to 7. And I'm going to be dramatic, and I'm going to put a question mark above the equal sign, which is wondering if that's true or not. Is the square root of 63 minus 2 times 7 equal to 7 or not? And, oh, do the math. So that's going to be 63 minus 14 equals to 7. Is that true or not? I don't know. 63 minus 14 is 49. Is square root of 49 equal to 7? It is. Okay. I mean, so 7 is a number. It's like the key that opens a door or something like that. It's a number that if you put it in an equation, it actually works. Okay. So is 7 a solution? And I would say yes. And that's my reasoning down there below. Okay. Now, sometimes an equation can have more than one solution, because just because you found one by accident or something like that, sometimes we guess and check if we don't know how to solve something. Doesn't mean it's the only one. Maybe negative 9 works also. So let's try. Same thing, right? I put that number in, 63 minus 2 times negative 9 equals to negative 9. Okay, put a question mark above it. Just to emphasize, I'm wondering whether this is true or not. This turns out to say 63 plus 18 is equal to negative 9, question mark. All right. That is 81. And it's come down to, is the square root of 81 equal to negative 9? And well, okay, so I have a real basic calculator. Even though I do math all the time, I don't have a fancy calculator, anything like that. This one's real simple. It's probably I don't know, $10, $15 calculator. There's nothing special about it. But if I type square root of 81 into it, it will tell me 9. It won't tell me negative 9. The square root of a number is positive by default, okay? So this one is no good. The square root of 81 is equal to 9. It's not equal to negative 9. Okay, so there I would say no, and I guess to address this question specifically, I would say no. Okay. All right. Now, so what does that say? I think you'll need some kind of basic calculator in addition to knowing what you're supposed to do when you solve a problem. If you have any questions about a calculator, how to use your calculator, if it's the right one, whatever it is, just let me know. I don't usually give advice about calculators because I find everybody has a different one, and what I say about one is probably not true about another. So if you have any concerns, let me know and I can help you that way. Okay, so now you know how to recognize a correct answer if you see it, okay? And I think that's a pretty good place to start, and I'll show you why with our next problem. Now, as I go through this, if you have a question, like I said, you can interrupt me, you can turn your microphone on, and just ask your question that way, all right? Okay, because I'm going to go through this very slow. For these meetings, I'm not going to make any assumptions about what you know. So it's going to be pretty slow. I hope it's not too slow, but I find through teaching math, it's better to go a little slow than a little fast, okay? All right, so let's solve this one. It looks kind of like that one that we were just working on, except for I don't have numbers that I'm telling you might be the answers, okay? All right, so different equations are solved in different ways. The way that you can learn to do this is by imitating what I do, either right now or in the videos, okay? So yeah, like if you see an equation in the assignment that looks like this, then you will probably work it the way that I'm about to show you. And I'll show you that that's true Because look, if I open the first assignment and I go to the first problem, this one looks a lot like this one. Okay? All right. Let's look at them. See how similar they look? Okay, so whatever I show you right now probably applies to this because it looks so much like it. Okay. Now, so here's the way that we can solve this one. In this equation, I need to get at the x. Okay, I'm kind of interested in that x. And I find that this square root is in the way. So here's what I do. We square both sides. Okay, all right. Now, two reasons for doing that. An equation has an equal sign, and so you can think it has a kind of balance in it. So what that means is what you do to one side, you need to do to the other. So if you want to square one side for whatever reason, then you need to square the other side to maintain the balance. Whatever you do to one side will do to another. Okay, so that's one thing. Another thing is that the square will cancel the square root. And I want to get rid of it because it's in the way. It's another thing that's in there. And you find when we solve equations, we gradually break them down simpler and simpler. How about this? Like I said, I didn't want to assume too much. So does squaring cancel a square root? You can just accept that because I said it if you want to. But how about let's demonstrate it? How about that? How can I prove that squaring cancels square root? Say I have the square root of 5 squared. Okay, well, let's see. What does squaring mean? To square something means you multiply it by itself. So the square root of 5 squared is the square root of 5 times square root of 5. Now, part of the reason I'm bringing this up is because I want you to see that, yes, the square and the square root do cancel each other. But I just want to tell you some things that you might need to know later on. Like, how do you multiply square roots? That's something that will come up at some point. Like, what's the square root of some number a times the square root of some other number b? Okay, well, the way that you multiply square roots is you multiply those numbers together inside one common root. Square root of a times square root of b is the square root of the number a times b. So this is the square root of 5 times 5. And therefore, it's the square root of 25. What's the square root of 25? It's 5. Okay, now what does that show you, though? That shows you that this just ends up being this. What do you see there? The square canceled the root and left you with the number that's inside of it. Okay, so I just wanted to demonstrate that. It gives me a chance to bring this thing up about how you multiply roots. All right, allows us to practice a little bit. So back over here, that square, yes, as a matter of fact, cancels the root. What's that gonna leave us with? 18 minus 7x on the left because of the canceling of the root, and x squared on the right. Okay, now, next thing that we do. Normally, if we see an equation has a square in it, like x squared, the way we solve it is by factoring. And if we do that, we'll need to get 0 on one side and factor the other side. So here's what I mean. I'm going to try to get 0 over here and collect all the terms together over there. I'm going to add 7x to both sides to maintain the balance. And I'm going to subtract 18 from both sides to maintain the balance, because that'll get me 0. negative 7x plus 7x gives me nothing. And 18 minus 18 also gives me nothing. So I get 0 on one side. And I get all this stuff, x squared and plus 7x and minus 18 on the other side. Okay, so like that. All right, now I got the 0. And all I need to do is factor this now. Okay? Now, I told you I would want to go through this slowly. All right. And I want to talk a little bit about what the word factoring means. So, say I've got 24. And I say that's 4 times 6. This is a two-way street. If I go this way, that's called multiplying. You know, if I give you 4 times 6 and you tell me that's 24, just because you multiplied. But if I go this way, that's called factoring. If I give you 24 and you tell me that's 4 times 6, then that's because you factored it. So, like right now, I'm telling you that I need to factor that. Now, and you'll see why after this step. But for now, you'll just have to trust me that that's what we need to do. So, well, what's factoring? If you take something and you break it into parts that multiply to get that thing back. So the kind of stuff I multiply to get that looks like this. It's x plus some number times x plus or minus some other number. Okay, that's the kind of thing I would multiply together to get x squared plus 7x minus 18. So the trick to figuring out what that number is supposed to be and what this number is supposed to be is this. I'm going to try to think of two numbers that multiply to give me negative 18, but simultaneously add to give me 7. Okay? And it just becomes a matter of figuring out what those numbers are. Are there two numbers that multiply to negative 18, but they add to get 7? Okay? But think about all the possibilities there. There's 18, 3 times 6, and then there's 2 times 9. What 2 times negative 9? That gives me negative 18. But if I add those together, it gives me negative 7. So negative 2 times positive 9. If I multiply those, that gives me negative 18. But if I add them, it gives me 7. That's what I want. X minus 2, x plus 9. Okay, that would be how you factor it. And if you multiply this back together, you'll get x squared plus 7x minus 18. You can always check factoring. Why is that? Because factoring is the reverse of multiplying. Is 4 times 6 correct? Yeah, because 4 times 6 is 24. So x minus 2 times x plus 9, sure enough, is x squared plus 7x minus 18. Okay, now, why do we factor? Well, there's this thing about 0, okay? If I multiply two things and I get 0, what can you tell me about those things? So if I say some number A times some other number B is 0, what can you tell me about A or B? How do you multiply two things and get 0? Well, 0, there's this, we like the number 0 in math, okay, because it usually simplifies things. If I multiply two things and get 0, then one of those things has to be 0. Okay? Because that's how multiplication works. The only way you can multiply two things and get 0 is for one of those things to be 0. Okay? So if a times b is 0, then one of those numbers has got to be 0. A is equal to 0, or possibly b is equal to 0. So that would be the case over here. I'm multiplying one thing, x minus 2, times another thing, x plus 9. So one of those things has to be 0. So either that first thing, x minus 2 is 0, or this other thing, x plus 9 is equal to 0. Okay. Now, well, let's see. Can you solve this and give me some ultimate answer about what x is supposed to be? If you add 2 to both sides, you'll get 2. And for this one, if you subtract 9 from both sides, you'll get minus 9. Okay. There you go. So it looks like we got answers then. 2 and negative 9. X equals 2, one answer. X equals negative 9, something else. All right, now I went through that really slow. I told you I wanted to go through it slow. I'm aware that that's much slower than some people would ever want to go through this problem, but I want to make sure that you got to see everything you needed to see. Okay. Now there is something else about this kind of problem, okay? These equations with square roots have this sort of a flaw to them, that you do everything right, and it's still possible that a false answer shows up. So here, I've solved it. I've done everything the right way. No mistakes. But that doesn't guarantee that these actually work. Okay, and I know that might sound weird, but that's the nature of this kind of problem. So, the last thing is that I have to check it. I don't check it just for my own conscience because I want to see that I'm correct, but that I've got to eliminate these false solutions that sometimes show up in this type of problem. Okay, so the checking it is a must. All right. Well, we talked about that, didn't we? How do you know if a number is actually an answer to an equation? You put the number in and you see if it makes it true. Okay, so let's see. 2. Is 2 going to work? Let's try. So I'm going to put it in that equation, the one that we started with, which was like this. Root 18 minus 7 times x is equal to x. Okay. I'm going to put my number in, and I'm going to see if it's right. So 2 and 2. Okay. So let's see. So this will be 18 minus 14, and that's going to be 4. And this is just 2. There's nothing to do with it. And it says the square root of 4 is 2. And that is, as a matter of fact, true. So 2 really does work. There was this possibility that it was a false solution, but I checked it and it works. And so it actually is. Okay, what about this negative 9? Let's try that. So root 18 minus 7 times negative 9 equals negative 9. I put the question mark to be dramatic about it because I'm trying to emphasize to you that I'm wondering if this is a true statement or not. This negative 7 times negative 9 is positive 63. And if I add 18, I'll get 81. And it says square root of 81 is equal to negative 9. Well, like, this should seem familiar. It's just like that problem we started with. If with my calculator, I check, is the square root of 81 negative 9? It's not. The square root of 81 is 9. It's not negative 9. Square roots, by their nature, are positive numbers. Okay? So, the square root of 81 even if I didn't know what it was, I know it's not -9 because square roots are not negative anything. So we're gonna cross out the -9 because it didn't actually work. That's what I'm talking about. That's why you must check, because one of those answers might not work. And it's not necessarily the negative one. It might be that they both don't work. It might be that they both do work. It might be that one or the other works, and you just find out by checking it. Okay. All right. So there's our first one. Now, if we were doing this on Mymathlab, then, it's working the problem. I just worked it out. I checked my answer like I'm supposed to, and so on. Then I just put that number in. I would check it, and if I was right, I would move on. Okay. All right. So let's try another one, and then in a little while I'll let you try some on your own, and you'll get some feedback on how you're doing. Okay, so let's see. Yeah, I remember we looked at one. Let's talk about these fractional powers. Let's see. Remember when we looked at this one? Yeah, we looked at something like this earlier. Okay, and it says x to the power 3/2. And it's not hard for me to show you how to do that, but I thought it would be good if I could tell you what a fractional power is. Like, what's 125 to the 2/3 power, Like, maybe take it like this, like 5 to the 3rd power. Do you know how to do that? It's 5 times 5 times 5. Okay? That's what exponents are. You multiply 5 by itself 3 times, 5 times 5 times 5, and then you do your math, and you get 125. Okay. All right. But how would you do 2/3? Like 125 to the 2/3 power. How would you multiply 125 by itself 2/3 of a time? All right. Doesn't really make sense. So I'm going to show you this. What is some number n to some power a over b? Okay. How do you calculate or interpret a fractional power? Here's how you do it. That number b is the root. And that number on top, a, is the power. Okay? So it's kind of like you have n, and the fraction is interpreted this way. For the number n, you apply this root to it, and then you apply that power. And it actually doesn't matter what order you do this in. You could do the a power first, and then take the b root. Doesn't matter. Okay? All right. Now, let's try that with this one. So what's 125 to the 2/3 power? Well, according to this, the 3 is the root and the 2 is the power. So I'm going to do 3rd root of 125, and then I'm going to do 2nd power. All right. Okay, so that's what it says. Now, what's the 3rd root of 125? Well, so that's the number you'd take to the 3rd power to get 125, but that's 5. 5 to the 3rd power is 125, so that's 5. Okay, all right. 3rd root of 125 is 5. And then 5 squared is 25. Okay, so that's how you calculate fractional powers by yourself. Okay. Now, you can also use a calculator, but it's not hard to push buttons. So I wanted to show you this. I mean, you'll need to know this for other reasons anyway. So that's one reason I told you. But also, I think just my responsibility, it's better that I get you to know stuff than not know stuff. So sure, you can sometimes do these fractional powers on a calculator, but I'd feel better if I showed you how to do it step by step too. I would just feel better that way. On my calculator, here's how I would do 125 to the 2/3 power. This is my calculator. I type in 125, and then my exponent button looks like this, okay? And then I would have to put 2 divided by 3 in parentheses. That's how I would do it on my calculator. So if you have your calculator and you're playing along, making sure that you can do this, you might have a button like that, okay? But you might have to put it in parentheses like me. Just go ahead and try it, but the answer is 25, okay? One thing, when I get questions from students, one common question, it just results from students not using their calculator the right way. They're not inputting things the correct way, okay? So the calculator makes it easy to do stuff, but it obviously doesn't work if you don't know how to use it. So at least if you know this, then if your calculator seems to be giving you an answer that you don't think is right, you can check it and see if it's right or wrong, okay? Well, let's try this one. One more. What's 25 to the 3/2 power? That would be the square root of 25 to the 3rd power. Square root of 25 is 5. To the 3rd power is 125, okay? All right. So now let's see something with that kind of number in it. So let's do this one. Okay, there it is. Now, that's a lot like some of the ones I've showed you in the first assignment. Okay, so let's talk about how you could do this. In an equation, there's a way that you deal with every number that's there. Okay? Like say I have, I don't know, 2x plus 1 is equal to 11. Generally, when we solve equations, the idea is that you start with the equation and you work it, and then your very last step reveals your answer. And you get that answer by getting the x by itself. So if I can reduce this to say x equals some number, that number is my answer. So the trick is, can you isolate the x? Can you get the x by itself? And there's a way that you deal with the 1, and then there's a way that you deal with the 2. Okay, so for example, all right, the way that you deal with the 1 is by subtracting 1 from both sides. That's how you do it. Okay, all right, and if you do that, you get 2x is equal to 10. And then see the 2 there. The way that you deal with that is different. The way you deal with that is you divide both sides by 2. Okay? All right, but then once you do that, you reveal the answer. 10 divided by 2 is 5. All right, now, same thing with something like this. How do you deal with the fraction power? What are you supposed to do to get it to go away? Okay? All right, there's a way that you deal with every number and every symbol in an equation. And the way that you deal with the fractional power is very simple. You invert it and you put it on the other side. Okay, so if I have the 5/2 power on one side of the equation, it's going to be the 2/5 power on the other side. That's the way that it works. Okay, it's kind of like this 1 on one side of the equation is actually a -1 on the other. And this 2 multiplying by 2 on one side of the equation is dividing by 2 on the other side. So 5, you see how there's like a backwardness to it. +1 is -1 on the other side. Multiply by 2 is divide by 2 on the other side. The power 5/2 on one side of the equation is the power 2/5 on the other side. There's a backwardness to it, all right? So all right, I get this, and how are you going to do this? You could use your calculator to find out 32 to the power 2/5 if you want to. You could do it like I showed you. Remember, I think it's good that you know how to do stuff. The more stuff I can teach you, the more stuff you know, the better, I think. So wouldn't it be like that? That's how we learned to do it before. It's the 5th root of 32 then squared. Okay, 5th root of 32 is 2, because 2 to the 5th power is 32, and 2 squared is 4. All right, so 4 is my answer. Now, on the problem I did before, I said that you had to check it. Remember this one. There are the possibility of false solutions showing up. The checking is not optional. Here, you can check it if you want to. You can plug in the 4 up here, see if it works. If it makes you feel better, maybe you're taking a test and you want to make sure that your answer's correct before you submit it. So yeah, the checking is optional on this one. Okay. All right. So anyway, now that's how we handle fractional powers. Now I want to show you this one. Okay. Do you think we would do anything different? So look, it's a little more complicated. It's got an extra number and so on, but we got to deal with the 3/2. I've got to do something with that. And I've got to deal with the 2, right? And if I can get rid of this number and get rid of that one, then I can get the x by itself and I'll have my answer. But we know how to deal with each of those numbers. Remember, we just talked about what you do with the fractional power. And we also talked about what you would do with the -2. The way we'll do it is we'll deal with that power first, and then we'll deal with the -2 second. Okay, so what do you do with that power? What do we say? A power of 3/2 on one side would be a power of 2/3 on the other side. Okay, let's figure out what this number is. Can you use your calculator? Yeah, you can use your calculator. But it's also this, right? 3rd root of 64 then squared. So 3rd root of 64 is 4. Okay, because 4 times 4 times 4 is 64. 4 squared is 16. So that number is 16. So that takes care of that fractional power. Now what about the -2? Well, a -2 on one side is +2 on the other side. So 18. Okay, 18 is our answer. We can check it if we want to, right? But if you do everything right, it's guaranteed to work. The only ones you need to check are the ones with the roots in them. Those are the ones you have to check. Okay. All right. All right. Well, how about why don't I'll give you a chance to try some. Okay. So let's see. Let me get this back up. How about this? Now you saw me work a few problems, and let's have you try some that are similar. Do you see this one? What I want you to do, try to do this on your own. Okay. And when you get the answer, you can turn your mic on, you can type it in the chat, and then we'll see if it works and we'll talk about it a little bit. Okay? If you have anything to ask as you're going through it, then you can ask. But let's have you try and work one.
So I thought that x is equal to
What was that? X is equal to
1.
1. All right, that is the right answer. Nice work. Very good. Okay, so you probably got 2 answers and you checked them and found out one of them didn't work. Can you tell me what that other one was?
So the other one that I had gotten was -6.
-6. Yes, that's right. -6 you ruled out and 1 worked. Very good. Very good. Great job there. Now, okay. So, but that's one that you solve just like this one. All right. Okay. Now, let me make sure. Anybody worked that was getting stuck somewhere or wasn't sure what to do? Maybe you got to a certain point, you weren't sure what to do next. Maybe you got a number that just didn't look right. Let me give you a chance to ask questions. Oh yeah, Armani says 1 and -6. Yep, that's right. Confirm that answer. Any questions though before we try something a little bit different? All right, so let's try something a little bit different. Let's try one like this. Okay, so we saw one that was a lot like this one too. Let's do the same thing. Try to do it on your own. And as soon as you get it, turn your mic on or type your answer in the chat, and we'll see if it's right. All right, so I'm getting 26 and 11, so 26 is the right answer. But let's go ahead and check it. I did this one in my head, and I'm not bragging about that. I'm just saying, like, I was looking at it, trying to work it out in my head, and I got 26. Let's try it out. So, what about this? X equals 26. I'm going to type that in. I think 26 is actually right, but let's see what Mymathlab tells us. And it says that's not correct. Okay, but I know 26 is right. I mean, I did this and I checked the math. But you know, Mymathlab is a computer and it doesn't know how to interpret your answer, and it doesn't know how to understand that you're really saying 26 is the answer. So when you know, this could come up, you could get the right answer. Mymathlab tells you you're wrong. If that's ever a concern of yours, go ahead and let me know. It's probably something I can clear up real quick for you, or I can go in and change your score. Remember, you know, you can send me a text anytime. Me and Melvin here, send me a text. Let me know if you're having trouble. I can probably answer you real quick. But the problem with this one is in Mymathlab, we just type in the number. We don't have to type X equals, okay? So yeah, 26 was correct. So, you know, let me tell you, it is easy to make mistakes in math. So Marisol said 11. So you may have made a miscalculation somewhere along the way with that power when you got 11, because 26 is definitely it. Let me show you, since 11 was also proposed. So let's see. That problem is x minus 1 to the power 3 over 2. Is that right? 3 over 2 is 125. Okay, so that fractional power, we're going to put that on the other side like this. Okay, we're going to turn it upside down, put it on the other side. And then that is the third root of 125 squared. And the third root of 125 is 5. And 5 squared is 25. So that number is 25. You could also do that on your calculator. 125 to the 2 over thirds power. So Marisol, if you're having trouble with your calculator, let me know. Let's see. Hold on a second. Oh, okay, I gotcha. That's a very easy mistake to make. But so we get 25, and then when we add 1 to both sides, that's how we get 26. Okay, all right. So let's talk about something a little bit different then. One of the other topics that comes up in this first assignment is functions. Okay, and we'll talk about functions for the rest of the semester, and probably, you know, no matter what you're doing, if you're going into a science field, a technology field, engineering field, whatever, you'll be dealing with functions of one kind or another. A function is like a formula. Think of it like this. Think of a function as a box, and it doesn't even have to be an equation necessarily. But a function is like this box where you put something in and you get something back out. Okay? So you put a number in and you get a number back out. That's what a function is. And it doesn't even have to be an equation. Anything that converts an input to an output is a function. Okay, that's the first thing. So like with this equation, well, this equation is a function because, you know, I put 4 in, that's the input. 4 squared plus 1 is what the formula says to do. That's 17, that's the output. Okay, so that's what a function does. An input goes in, an output comes back out. Now, we use this function notation as a simpler way to represent this box. So if you have the notion, if you have the idea that a function converts an input to an output, then all right, you've got the right idea. But the simplified way to put that is with function notation. So with this, the way that we write this equation as a function is we use this symbol right there, f of x. So you read it like this. F of x, function of x. It says f of x is x squared plus 1. And this function notation is just a way of connecting the input and output. So instead of drawing the box and saying that you put 4 in and you get 17 back out, we'd say f of 4 is 17. And that says for the function, it's just a symbol. It says for the function, 4 is the input and 17 is the output. Because a function is just inputs and outputs. Inputs and outputs. That's all it is. Okay. All right. So so much. I mean, I think it will really simplify things if you learn to think of functions like this. Okay. Or if you learn to think of functions like this, that you understand that it, whatever it is, it just converts an output from an input. All right. Now, so let's do this. In addition to knowing or understanding what a function is, we'll have to connect that to being able to read information from graphs. Now, you're going into science, technology, engineering, whatever you're doing, people like graphs. It's an easy way to summarize a lot of information. So we've got to be able to read information from graphs, okay? It's an essential skill. So let's see. Let's do this. For this graph, X is left and right, Y is up and down. And some of the points are labeled. So like if this point is 4 and 1 right there, then that means that if I had graph paper or, you know, something like that, then I would go right 4 spaces and I would go up 1 space. Okay. Now I don't have graph paper right here, but you'll have to use your imagination that that's what I mean. It's also true that when we write points like this, that first number is x and the second number is y. Okay, so this point says that if the x is 4, that means the y would have to be 1. Now, connect that with reading this function notation. So this first thing I'm asking you, f of 4 is equal to what? Okay, so you think about like this. It's saying if you put x equals to 4 in the function, what do you get y to be? Can you read the information on the graph in order to figure out what y is supposed to be if the x is equal to 4? That's what it's asking us. It's not really asking us anything complicated. I think you'll find that so much of math is learning to read the symbols. The symbols make it look complicated or difficult, but if you learn how to read the symbols, math becomes a lot easier, I think. Okay. So yeah, that's all that this one is asking us. If x is 4, what's y supposed to be? You look at the points. Does any one of them tell you what y is supposed to be if x is 4? This one does right here. Okay, this point right there tells you that if x is 4, it turns out that the y is equal to 1. That's how I answered this first one. That's how I complete it. It says f of 4 is equal to 1. It says that this graph right here represents a function. Because if I put a number in, I get a number back out through these points. These points tell me what the ins and outs are. If I plug in 4, I get 1 back out. If I let x be 4, the y turns out to be 1. They're all different ways of saying that. Okay, so that's the first one. What about this one? F of x is equal to -1. Well, so it's asking us another question. Let me see. Remember, when you write the function notation, that number is the input or the x, and this number is the output or the y. So I guess what this one's asking us is, for what x is y going to be -1? For what input do you get -1 for the output? Okay, so let's summarize it like this. Because here, this one I don't think is hard or complicated. There aren't a lot of steps to it, but it's like it's saying what x gives y to be -1, and your answer is somewhere over here. So this one says if x is 10, y is 4. This one says if x is -1, y is 2. And then this one says if x is -7, then the y will be -1. Well, that's the one that we want. That's the one that gives us an answer to this. Okay, so right there, that's the point that's relevant to what this one is asking us for. So we'll say f of -7 is -1. Okay, so there are several questions on the first few assignments that are just about reading information from graphs like this one. So these two I put in the box, all right? So that's one thing that we'll need to know how to do is read function notation, read information on graphs that's connected to it, all right? Another thing is we'll need to be able to do calculations. All right, so let's say that we have this function, like that. This is what we start with. You have some kind of function. What's a function? If you give me an input, I'll calculate what the output is. If you give me the x, I'll calculate the y. That's what a function is. Okay? Why I calculate it? Maybe I just read the information from a graph. Like here, what's the equation? Well, there's not always an equation. Maybe this is just data from a laboratory or something like that. There's not an equation that fits every circumstance that's out there. Okay, so here I don't have an equation, but I understand that the graph is telling me the x and the y. So here I do have an equation, and I could find out you know, the y or the output by doing the math. Okay, so all right, what's f of -5? Well, that's just saying that you let x be -5, and it's asking me for what y is. It's saying that I'm plugging the x in and asking what I get back out as a result. Okay, well, see, there's your formula. How do you think that you would use that? You plug in the -5 into where the x is, and you square it, and you add 1. Okay, so let's see, -5 squared, that's -5 times -5. So that's 25 plus 1 is 26. So here it was asking me for that answer, that output is 26. All right, so what about this one? And this one sometimes throws people off, way off the first time they see it. See, this one says, what's f of x minus 2? So here's my concern, that you'll confuse this x with this one up here, okay? And as a result, you'll just plug in like -2 in there with the x or something like that. All right, so, but let me show you the connection between the two of these. Both of them are giving me the input. You know, this one is -5, and here the input is x minus 2. So it's, trust me, like when you do algebra and more complicated math and science and engineering, there are lots of variables. Math would be easier if everything was always a number, okay? But here we have an unknown, x minus 2, but that's what's going in. Now, maybe think of it like this. Now, I know I'm over-explaining this, but I'm trying to appeal to how everybody might think about it, okay? Here's how I think about that. I think about a function like this. This function is the input squared plus 1. Whatever you plug in, squared plus 1. Why would I think about it that way? Well, because then I don't get all the x's confused with each other, okay? So like if you take this function and you plug in -5, you put it right there where that input goes. This is what the x stands for. The x tells you in this formula where the input goes, whatever it happens to be. If x minus 2 is the input, same thing. It goes right there in that parentheses. Okay? All right. Now, if that's the case, if the function that we're working with is the input squared plus 1, all right, then I'm going to put this as the input. Okay, now I know that that's over explaining it, and it doesn't have to be that complicated. And some people have a good intuition about math, and they wouldn't need me to tell them this in order to do it. But just in case it seemed really weird and you would have had the wrong instinct about what to do, I wanted to tell you all that. All right, now, how do we proceed from here? You know, like this one, I did the calculation. I took -5 and I squared it, and I got 25, and then I added 1. I need to do the same thing here. I need to combine, cancel, collect all the numbers that I can. All right. So let's see. How do you do x minus 2 squared? Here's what I'm afraid of. If we said x minus 2 squared, maybe you'd think of it like, all right, I need to square each of those. So I got x squared, and I got the minus, and then I got 2 squared. Okay, that's tempting. People do that. I've seen that done many times. But that you'll find that that's not actually the right way to go. And how do you know that that's not the right way to go? Well, because what does square mean? To square something means that you multiply it by itself. Okay. So if I take x minus 2 and I square it, that means that I take x minus 2 and I multiply it by itself. That is how, That's what I did with -5 squared. -5 squared is -5 times -5. It's positive 25. This wouldn't be any different. So x minus 2 squared is x minus 2 times x minus 2. All right. And then how do you multiply that sort of thing together? Well, we use FOIL multiplication. X times x is x squared. X times -2. -2 times x. -2 times -2. I get like this. And then I can combine some of this stuff. Okay, that's how you do it. See, you don't just apply the square to the stuff that is in the parentheses. You got to multiply it all out. X minus 2 squared is x squared minus 4x plus 4. So here's what this converts to as I calculate it. X squared minus 4x plus 4, and then plus 1. Okay. All right. All right. So is there anything else? Like, so as you do math, for whatever you're doing it for, we simplify as we go along. If we can combine something, we can combine it. If we can reduce it, we reduce it. So I look at this, like at any stage of a problem that I'm at, and I try to figure out, is there something else I can do to reduce it? Do I have to have all this stuff, or can some of it be combined? And I'd say, well, I got 4 and 1. I can tell you what 4 plus 1 is. That's 5. I might as well say 5. Okay. Okay. All right. And then that's as much as you can reduce it. You can't add any of these other things. Okay. Anyway, okay. So that's what you do there, taking it as far as you can go. You'll find something like all 3 of these plus this one in the assignment. So, like, for example, just to show you around a little bit, here's our assignment. And I say getting over to, yeah, so this one, that's a lot like the one I just showed you. Then there are some with a graph too. We looked at one like this. And I don't think it'd be good if I ask you to do this one all together, because it might be hard to see this graph on Teams, even though you can zoom in. But what's that one saying? It says, according to the information on this graph, if x is -2, what's the y supposed to be? That's what it's asking you to put in right there. Okay. And if you look at this graph, this grid, and you zoom in on it, you can probably tell, but I don't know that it would show up clear enough on Teams. So we won't do it that way. Okay. Let me see if there's one more type of problem I wanted to show you. Okay, so let's try this one. This one is like, I think, the very last one in the assignment. Let me look. Yeah, okay, you see that? This is the very last one. Looks a lot like this one. So let's talk about how to work that, because I think this one might be the hardest one in the assignment. So this one is like the last problem in the first assignment, but it's also like this first one a little bit, in that it has a root in it, and we're going to square both sides in order to cancel the root. Okay. All right, so here we are. The thing is, if I square both sides right away, since there's not one root all by itself, it will sort of make a mess over here. So I'm going to move this term. I'm going to move one of these to the other side, so that if I square whatever is left on this side, it will cancel the root right away. So I'm going to move this to that side, like that. Okay. Then, like I did on that first problem, I'm going to square both sides. Okay. What's that going to do, though? That will cancel the root on this side. The root of x squared, the square and the square root cancel, will just get x. But what do I do over here? What's 2 minus root x minus 8 squared? Well, that's kind of like that thing I just showed you. We'll have to multiply this by itself. Okay, I mean, that's more complicated than this one. So 2 minus root x minus 8 squared is 2 minus root x minus 8 by itself. So like that, multiply it by itself. All right, so take note. Now, how would I do that? I would use FOIL multiplication again. First, outside, inside, last. 2 times 2, 4. 2 times negative root x minus 8. Negative 2 root x minus 8. Negative root x minus 8 times 2. Negative 2 root x minus 8. And last, I get negative root x minus 8 times negative root x minus 8. Well, a negative times a negative is a positive, but root x minus 8 times itself is x minus 8 because that's like squaring a root. When you multiply a root by itself, or it cancels, that's like root x squared is x. Other example, root 7 squared is 7. Root x minus 8 times itself is x minus 8. Okay, so this is first. This is outside. This is inside. This is last. So that's how I got that. Now, remember I said at any stage in a problem, I want to combine, consolidate any of my numbers. So I get 4 and negative 8. Those can be combined. That's negative 4. These are also combinable. You can add anything that's the same. So negative 2 root x minus 8 and negative 2 root x minus 8, it's going to be negative 4 root x minus 8. It's like if I had, anything that's the same. If I had negative 2m minus 2m, well, these terms are the same in that they both are m. That's negative 4m. Same thing with the negative 2 root x minus 8. And then I get x. And that's the most I can combine out of that. So, okay, let's look at this. Negative 4 minus 4 root x minus 8 plus x, right? All right. So now what? I still got this one root left over. So if I can get that by itself again, and if I can square both sides again, then I can remove it. All right. So I'll have to do that before I can get all the way to the answer. But let's see. I'll add 4 to both sides to get that gone, to get this by itself, and then I'll subtract x from both sides. Okay, and then this is what I'll have left. X minus x cancels, leaving me with just 4. Cancel, cancel, leaving me with just negative 4 root x minus 8. Now I'm almost there. I divide both sides by negative 4 in order to eliminate this number. Okay. And I get negative 1. I cancel here. And I get root x minus 8. Now, okay, down to the final step. So I got this root by itself. I squared it in order to cancel it. That left me with this other one, which I got by itself. Which again, if I square both sides, we'll cancel it. So what's negative 1 squared? It's 1. What's root x minus 8 squared? X minus 8. What's the x? If I can get the x all by itself, I have my answer, and that turns out to be 9. All right, I add 8 to both sides, I get 9. Okay, so there's my answer. But remember when we were working earlier on this one, that one with a root in it, and I said that you must check. Sometimes false answers show up. So we have to rule them out. So here I must check. Anytime I work with an equation that has a root in it, I might get a false answer. So 9, okay, it might work, it might not. I have to check. And it's not because I did anything wrong. It's not because I may have made a mistake. It's just because even if I do everything right, the nature of this equation is that I might get a false answer. But it doesn't take long to check it. So let's see. I put 9 in for the x. And just to be dramatic, I'll put a question mark over the equal sign. I want to know if this is true. So let's see, that's a 3 plus, and then 9 minus 8, that's 1, and the square root of 1 is 1. And it says 3 plus 1 is equal to 2. Well, 3 plus 1 is definitely not 2. 3 plus 1 is 4. So it doesn't work. The only number I got that could have possibly been an answer didn't actually work out. Okay, but that's the way it is. There are unsolvable problems in math and in science and engineering. It can happen. No way to solve this one. There's no number out there that works. If there was an answer, we would have found it when we worked it. The one number that I did find didn't actually work out. Okay, well, so what's that mean? Notice that in Mymathlab, like for this one, it says option A, the answer is, and we can put our answer in if whatever we think it is. And option B, the solution is the empty set. Well, that's a way, that's an unnecessarily fancy and complicated way of saying there isn't an answer, okay? So, all right, for this one, if I was working that same problem on Mymathlab, I would select the solution set is the empty set, okay? And I would just check it that way. All right, turns out for this one too. So, all right, I'll say this, no solution. I think that's a better way to say it. I think that gets the point across a little bit better, but I did show you on Mymathlab that you choose that second option B if there's no solution. Okay, now that's like the last 2 problems on the assignment. I wanted to make sure that I got to that because I think those last 2 are probably the hardest that are on there, okay? Anyway, now, so today I told you how to get started in the class. I explained how to find everything on Canvas. I explained how to use Mymathlab, how to find that, etc. We did some problems. Now you're ready to look at the first assignment. Is there anything else that you want to ask about or say before we're done? So remember, as you work on the assignments, you can text me and Melvin here and ask for help. Just say I'm in 1314-82001, and my question is whatever you want. Now, I don't do school 24 hours a day, 7 days a week. It might be sometimes that you text me on the weekend and it takes me a while to get back to you, but I think all things considered, this is probably the fastest way to get help. So I'll give you that number just because I think it'll work out the best for all of us. Okay. Okay, so last chance. Anything else? I will send the link for our meeting next Saturday out on Friday afternoon, Friday evening. and you should get it to your My TCCD email, okay? That's the one that I'd like you to use for the class. Okay, all right, well, we're done for today. Good luck as you work on your assignments this week. Text me if you need help. And otherwise, I'll see you next Saturday.